An AI agent just deleted the entire file system on a developer's machine, not a test environment. The actual machine. That's a real category of incident that's happening right now as more teams let AI agents run code autonomously. And the terrifying part is that most current setups have zero isolation between the agent and the host. SmolVM exists to fix exactly that. SmolVM is an open source sandbox built specifically for AI coding agents and computer use agents. The idea is simple, but the execution matters. Every time your AI agent needs to run code, click through a browser, or interact with a desktop, it does all of that inside a disposable virtual machine. Not a Docker container, an actual lightweight VM. When the task is done, the VM disappears. If the agent does something catastrophic, wipes a directory, installs malware, runs an infinite loop, none of that touches your real system. Let's talk about what this looks like in practice. You're building an AI coding assistant that can write and execute code. Without a sandbox, when that agent runs code, it runs on your machine with your permissions. With SmolVM, you spin up a fresh VM for that agent session. The agent gets a full Linux environment. It can open a browser, interact with a GUI, run terminal commands, install packages, everything a computer use agent needs. And you, on the host side, can observe what it's doing through a clean API. When the session ends, that VM is gone. Clean slate. No residue. The VM startup time is fast enough to be practical. We're not talking about waiting 5 minutes for a full OS boot. SmolVM is built around lightweight virtualization that targets sub-second to low single-digit second spin-up times. That matters enormously when you're building agents that might need to spawn dozens of sandboxed sessions in a pipeline. What surprised me when looking at this project is how the API is designed. Rather than bolting a sandbox onto an existing tool, SmolVM exposes clean primitives. Create a VM, push a task, get output, destroy the VM. That composability means it slots into agent frameworks without fighting the architecture. But here's the thing, SmolVM is not a complete agent framework. It does not give you the AI model. It does not give you the planning logic. It does not give you memory or tool orchestration. If you come to SmolVM expecting a drop-in solution that makes your GPT-4 agent safe, you'll be disappointed. What you get is the execution layer, the sandboxed environment where code actually runs. You still need to bring the brain. And there are real limitations worth naming. Persistent state across sessions is something you need to handle yourself. SmolVM VMs are deliberately disposable, which is the point. But if your agent workflow requires a memory of past actions inside the environment, you're responsible for serializing and restoring that state. That's not trivial. Performance at scale is another open question. Running 1 or 5 sandboxed VMs is clearly fine. Running hundreds concurrently on a single host is a resource conversation you need to have with your infrastructure. If you're deploying this in production at scale, you're going to want dedicated compute, something like DigitalOcean's GPU droplets, or a dedicated VM host where you control the underlying resources. The library itself doesn't manage cluster-level orchestration. Also, GUI-based computer use is supported in principle, but the agent's ability to actually navigate a real desktop environment depends heavily on how you're feeding visual observations back to the model. SmolVM provides the environment. What you do with the screen output is on you. Now, what could this realistically become? The most compelling near-term direction is tight integration with popular agent frameworks. Think LangChain, AutoGen, CrewAI. Right now, plugging SmolVM into those stacks requires some manual wiring. If the project ships first-class integrations, a LangChain tool that wraps a SmolVM session, for example, adoption accelerates dramatically. Developers building on those frameworks would get sandboxing essentially for free. The other direction is snapshot and restore. Imagine an agent that explores a codebase, reaches a decision point, and needs to try 2 different strategies. With VM snapshots, you branch the execution environment, try both paths in parallel, and keep whichever succeeded. That's a completely different class of agent capability. SmolVM's architecture doesn't block this. It's a natural extension. There's also an interesting story around reproducibility. If every agent run happens in an identical, fresh VM, debugging becomes dramatically easier. You can replay any session with the same environment state. For teams building serious AI products, that auditability is actually a compliance and safety story, not just a developer convenience. So why does this exist? The honest answer is that the AI agent ecosystem moved faster than the safety infrastructure around it. We have increasingly capable agents that can write and execute code, browse the web, interact with GUIs, but the default execution environment for most of them is wide open. The agent runs as the user on the user's machine with the user's credentials. That's a disaster waiting to happen at scale. SmolVM is a bet that the execution layer deserves to be a serious engineering concern, not an afterthought. It's not the only approach. Browser-based sandboxes, E2B, Daytona, modal functions. There's a growing ecosystem here, but SmolVM is open source, lightweight, and composable in a way that lets you actually understand what's happening under the hood. For developers who need to deploy coding agents and don't want a black box sitting between their agent and the underlying compute, that matters. If you're building anything with autonomous code execution right now, this is worth understanding even if you don't adopt it directly. The next episode covers how teams are combining sandboxed execution with tool calling agents to build workflows that can actually ship to production. Subscribe so you don't miss it.